Is it true that concrete beams crack?
Yes, it's absolutely true that reinforced concrete beams crack. Just imagine we had a reinforced concrete beam in front of us between two supports and we loaded it in the middle. If we did that, then what would happen is the concrete at the top would go into compression and the steel bars at the bottom would stretch. But of course the concrete surrounding that steel bar at the bottom is also in tension. So what happens is the beam deflects downwards and the concrete cracks. And after that cracking has occurred, after the load has been removed, what will happen is the beam will return to its original position and the cracks will close. So here we have a reinforced concrete beam which is being loaded. And as it gets loaded, note that it moves downwards, it deflects downwards, and cracks will open. When the load's removed, the beam returns to its original position and the cracks will close.
So how much steel do you need?
That's a very good question. It's going to take a little while to explain. I need to give you some background. To start with, you might think that you need a whole lot of steel in a reinforced concrete structure. That feels correct, doesn't it? It's not true. As it turns out, structural engineers look at failure a lot. We have to understand how things will fail. And in fact, the amount of steel that we put into a concrete structure can dictate the type of failure that we get in concrete structures. And we need to be very mindful of that. Remember that we have two materials in reinforced concrete. We've got the concrete and we've got the steel. And as a structural engineer, we need to decide which one we want to fail first. So let's look at this reinforced concrete beam under test conditions. This particular beam, we've put too much steel into this beam. It is what we call an over-reinforced concrete beam. So under this loading, this reinforced concrete beam fails explosively and suddenly, and the concrete fails first. Right, now let's look at a completely different sort of beam. This is also a reinforced concrete beam, but in this case, we have under-reinforced the concrete beam. We haven't put very much reinforcement into it. Now watch it carefully under load. As it's under load, it begins to deflect, and it deflects far more than the previous beam we saw, has far more cracks, and that's because the steel is stretching, and in fact the steel is yielding, which means that in this particular case, it's the steel which fails first rather than the concrete. So now we understand how the amount of reinforcement that we put into a concrete structure can control the type of failure we get. If we over-reinforce a concrete beam, we get an explosive, brittle behavior. And if we under-reinforce a concrete beam, then we get a nice, gradual type of behavior. So as structural engineers, which one would we prefer? The brittle behavior or the gradual behavior? Well, it's pretty obvious we prefer the gradual behavior. So that's what we do. We design concrete structures to be under-reinforced. And what does that mean? To answer the original question, it means actually we put about 1% steel reinforcement into most reinforced concrete structures. And that 1% value might surprise you.